Okay, so we're now being recorded. If you have a question, you can type in the chat box or you can type in the Q&A box, and I'll check through periodically to see if there are any questions along the way. So these are the topics we're going to be covering in this session. We're going to take a look at fair division games and define the elements and take a look at some assumptions that go along with the fair division game. We're also going to calculate a fair division problem and then look at 3 specific methods with calculating fair division. There's the divider-chooser method, the lone divider method, and the lone chooser method. So we'll be looking at examples of all of those in this session. So the question is, how can assets be fairly divided where everyone feels they got more than they deserved? When different people have different values, the fair market value is in the mind of each person. Thus, dividing something equally does not necessarily mean dividing it into equal physical pieces. So if you have a piece of cake, for instance, and there's 3 people, that doesn't necessarily mean dividing the cake into 3 equal parts where each part looks physically the same size. What makes this chapter challenging is that you have to think like the person who's doing the dividing or doing the choosing to see if how they see things to be divided equally. So we're going to be looking at the value in the mind of each person. And that takes a little bit of getting used to, so that's why we're going to do several examples. Okay? The assets are the goods being divided among the players. And so if there are n players, then each player sees their fair share worth at least 1 over n of the value of the goods. So if there are 2 players, then each player should see that what they received is it worth at least half. In their mind, what they receive is worth at least half. The value of the goods could be different to different players. So when determining a player's fair share, the value in that player's mind needs to be considered. Okay, the fair division of assets occurs when each player sees their share to be worth at least 1 over n of the assets. So, and a fair division method is one that is guaranteed to achieve this goal. So there's different methods that we can follow to make sure each player sees their share to be at least 1 over n of the assets. So there are a few assumptions as we go through this for every single example that we are going to do. And the first assumption is that each player is thinking rationally and is not trying to play mind games. So it's not like where you go like circular reasoning, like I'm going to pick this one, but you know I'm going to pick this one, so I'm going to pick that one, but you figured I would know I would pick that one, so now I'm going to go pick this one. For instance, that type of reasoning is not, does not have a part in these fair division games. So no mind games going on. The second thing is that each player is willing to play by the set of rules. So whether it's the whether it's the lone chooser method, the lone divider method, whichever method is being used, all of the players are okay with that particular method. The third assumption is that each player is unaware of the other player's value system. So player A does not know what player B is thinking. And the fourth assumption is that each player has the same right to the assets as each other player. So all equal there. And these assumptions are really for the entire chapter, for every fair division situation that you come across. Okay, so here's an example. Let's say we have 4 partners. We'll just call them A, B, C, and D, and they jointly own a piece of land with market value of $500,000. So let's say we divide it up into 4 shares. And I'm not sure, you know, it doesn't really matter exactly where the lines are drawn. It's just that there are lines drawn so that this piece of land is in 4 now 4 shares. And the partners are splitting up, and so each partner is going to get 1 share. But each partner sees the shares differently. Now the fair share is going to be $125,000 each because it's $500,000 divided by 4. So each player should get at least $125,000 worth of property. Now you may think, well, all you have to do is take the land, divide it up into 4 equal pieces. Each person gets $125,000 and that's it. But that is not the situation, because when each partner looks at these 4 shares, they see something different. Each partner looking at it sees things differently. So we're going to take into account what's happening in the mind of each partner. So let's take a look at partner A. So partner A, S4, which is share 4, that's the notation for share. So S4 is share 4 is worth $60,000 more than share 2. And according to partner A, shares 2 and 3 are equal in value. But share 1 is worth $30,000 more than share 4. So using some variables like with equations, we can say that S4 is $60,000 plus S2. We can say S1 is $30,000 plus S4, and then S3 and S2 are equal. Okay, and we know that adding up all 4 shares gives us the total value of $500,000. And we're going to use that to write an equation like this, that when you add up all 4 shares, you get $500,000. But what we need to do is write it so we can solve for something. So if I go back here, it looks like I can write everything in terms of S2, because I can take out this S4 and put what it equals. So I could take that out and put it there, and I could write S1 as $30,000 plus $60,000 plus S2. And I could, anywhere I see an S3, I could put S2 because they're equal to each other. So let's do that here. I take out S1 and I put $30,000 plus $60,000 plus S2. So this is substituting for S1 right there. And again, how I did that, we go back here, that S1 is $30,000 plus S4, but S4 is $60,000 plus S2. So S1 is actually it's actually the $30,000 plus $60,000 plus S2. So I took out S1 over here, and I put $30,000 plus $60,000 plus S2, and then the S2 I just brought down right there, and then I took out S3, and in the place of S3 I put S2 because we're told S3 and S2 have equal value. And then instead of S4, I wrote S2 plus 60, I wrote S2 plus 60,000 because S4 is S2 plus 60,000. So you put all that together and solve for, S2 plus 60,000, that's this right here. Put all that together and solve for S2. So there's 4 S2s, so there's 4 S2s. And when I take 30,000 plus 60,000 plus 60,000, it gives me 150,000. And so then I subtract 150,000 from both sides, divide both sides by 4 to get S2 is 87,500. Now that I know that S2, I was just checking to see if there are any questions. Just to let you know, we are being recorded, but if you have any questions, again, there's a chat box and there's a Q&A box. So feel free to type your questions and I will check that periodically to see if there's any questions. So I was able to solve for S2, which then I can go back to this right here, and if I know S2, I can find S4, and if I know S4, I can find S1, and if I know S2, I can find S3. So I can find the value of all 4 shares to player A. So, to player A, those are the values of each of the 4 shares that land was divided into. Now, remember that the fair share is at least $125,000, which means player A could be awarded share 1 or share 4, either way. And it could be either one of those could be partner A's fair share. Are there any questions about how came up with that? Any questions up to this point? I'm looking, I don't see any. But feel free to type your questions in the question box or the chat box. Okay, so the same process continues with players B, C, and D, and in the end, this is how it works out. Player B sees the 4 shares. Now, this is the same 4 shares that we were just talking about. It's just in the mind of player B, that is the value of each of those 4 shares. Partner A and partner B are looking at the same exact 4 shares of land. They just see them differently based on their own values in their own mind. And when partner B looks at the 4 shares, that's the value that partner B sees. So if you notice, there are 2 options that are over $125,000, share 2 and share 4. So partner B could be assigned either of those. Partner C sees the same 4 shares of property, but this is the value that partner C is looking at when partner C looks at those same 4 pieces of property. Now, the fair share is $125,000, so shares 3 or 4 are an option for partner C. For partner D, same exact 4 pieces of property, but this is what partner D sees, and notice there's only one option that's higher than $125,000. So share 1 is what partner, partner D will be taking. Now we go back to partner A. Partner A could receive share 1 or share 4, but share 1 is taken by partner D, so partner A will receive share 4. So now we just have to figure out partners B and C. Partner B could receive shares 2 or 4, but share 4 is already taken by partner A, so partner B receives share 2. Partner C could receive share 3 or 4, but since share 3 is the only one not already taken, partner C receives share 3. So let's see how this all summarizes. In the end, each partner receives a share worth at least $125,000. Partner A, share 4, and according to partner A, share 4 is worth $147,500. That's in partner A's mind. And in partner B's mind, partner B is assigned share 2. And in partner B's mind, that is the value of share 2. According to partner C, this is the value of share 3. And according to partner D, this is the value of share 1. The key is all 4 people are getting a share that in their mind is worth at least $125,000. So they all walk away happy. Some happier than others. For instance, partner B is walking away with what in his mind is $170,000 worth of property. Okay. So the key with this, again, is also that you need to be thinking about how each person is viewing the situation, because each person will be viewing it differently, and you have to think in terms of how that person sees the situation. Okay, let's take a look at a method called the divider-chooser fair division method. This one could be summarized as you cut, I choose. So it's just another method of pretty much doing the same thing, but this normally has two players. You have the divider, divides the assets into two parts, and then the other player is the chooser. They pick the share that they want, and then the other piece goes to the divider. And a fair way, like flipping a coin, should be used to determine which person is the divider and which person is the chooser. Okay, so here's an example. Let's say we have John and Kara bought a half meatball, half turkey, foot-long sub for $8. So it's 6 inches of meatball, 6 inches of turkey, and the sub costs $8. Now, John likes meatball subs 3 times as much as turkey subs. That's how John sees the sub. How Kara sees the sub is she doesn't like meatball at all. She wants nothing to do with meatball. So she likes turkey, doesn't like meatball. Suppose they flip a coin and John ends up being the divider. So how would John cut the sandwich into 2 shares so that he sees each share as equal in value? Now, it might be your first instinct to cut it in half, where you have 6 inches of meatball and you have 6 inches of turkey, but that is not, we'll come back to that, that is not going to divide it into 2 equal in value pieces, because John values the meatball 3 times more than the turkey. So if you cut it right at the 6-inch mark, the meatball half will have a lot more value than the turkey half. So that is not dividing it so that there are equal value pieces. Okay, so we're not looking at the amount of food, 6 inches, 6 inches. We are looking at the value of the sub. So if we let X represent how much he likes the turkey portion, and 3X represents how much he likes the meatball portion, because we were told it's 3 times as much, then at 3X plus X represents the whole sub. 3X would be the meatball, X is the turkey, and that's a total of $8. So when we solve for X, we get that X equals 2. So what that tells me is that if I assign 2 to the turkey portion, and then I would assign $6 to the meatball portion. Okay, because remember the whole sub cost $8. So here I have $2, here I have $6, it adds up to $8. And if you notice, I take the turkey times 3, gives me the meatball, which is how John, notice I wrote John, that's how John sees the sub. Now we use this little bracket notation to show that's the first 6 inches, and then this bracket from 6 to 12 shows what that's the second 6 inches. So meatball goes 0 to 6. This is meatball, and then turkey goes 6 to 12. So it's divided up like that. But we're not going to cut at the 6-inch mark, because that would make one share $6, the other share $2. But we need to divide it so that each share is worth $4, so that it would be equally divided. Now, since the meatball, 6 inches, is worth $6, that means on the meatball side, each inch is $1. When we look just at the meatball side, each inch is $1. Now, I want to cut this so that one piece is worth $4 and the other piece of the sub is worth $4. So to do that, I'm going to cut right here on the 4-inch line, because on the meatball side, each inch is $1. So that makes from 0 to 4 worth $4. So that tells me from 4 to 12, that's the other $4. So I have $4 on this side, and I have $4 on the other side. of that line. So physically, I did not divide it in half, but it's not asking me to do that. It's asking for the cut to be made so that each share has the same value, which is different than has the same amount of food. Okay? So after John cuts, Kara gets to choose. Which share would Kara choose? Well, to make that decision, we need to look at how Kara sees this situation. Kara's looking at share 1, Kara's looking at share 2, and has to make a decision. How does Kara value the sub? She does not like meatball subs at all. So if we look back here, share 1 is all meatball. So she would not pick that side. She would pick share 2, which is the turkey, which goes from 4 to 12. That means John gets the 0 to 4. So since John did the dividing, he's left with what's left, which is from 0 to 4, which is $4. Okay. Let's see if Kara feels like she has her fair share. Well, Kara does not like meatball subs at all, so the entire $8 is devoted to the turkey. So S1, which is all meatball, would have a value to Kara of 0 because she doesn't like meatball, she wouldn't eat it, so it doesn't do her any good to have a meatball sub. That means S2, the second share, has to have the entire $8. So when she chose S2, the fair share would be $4. She gets more than that because she's getting something that to her is worth $8. So she did get at least her fair share. So in the end, each player receives at least their fair share, so they are both satisfied with the outcome. I'm going to check the chat box again real quick and the question box to see if there are any questions. I don't see any. Again, I thank you for taking the time to join. This is being recorded, and these notes I will email to your instructor when the session is over. So you don't have to frantically write everything down. But if you have questions, feel free to use the chat box or the Q&A box that you see. Okay, so let's take a look at another method. This one's called the lone divider fair division method. And with this one, this one works good if you have more than 2 players, because the method we just did was for 2 players. One person cuts, the other person chooses, and you're done. But this one you can use if there's more than 2 players. There's one divider, and the rest are choosers. That's why it's called lone divider. You have one divider, everybody else are choosers. The process starts when there is a random selection, like flipping a coin, to determine who will be the divider. So after the divider divides the assets into n shares, so n is the number of players. So if you have 3 people, then the divider will cut into 3 pieces. Now remember, the divider's not going to cut into 3 equal physical looking pieces necessarily. It will be in the mind of the divider how that divider is viewing whatever that object is, whatever the asset is. They will cut it into what they see as equal in value shares, okay? The chooser list then, so after the divider cuts, then the choosers, which is everybody else, they look at all the shares and they write down what they would consider to be a fair share according to their value in their head. So let's say there's 5 players. So after the divider cuts the assets into 5 pieces, each of those players gets out a piece of paper and they write down, they look at all the shares and they write the shares that they think would be their fair value, okay, fair to them. And then also, if they write more than 1 share down on their paper, it's a good idea to indicate which is preferred. Like if they see shares 2 and 3, they prefer 1 over 3, it would be good to write that down on the paper in case there's a tie with another person, okay? So maybe even listing them in order of preference and go from that. If more than one player wants a share, then you can use that preference to indicate the distribution. In the case where there's a case where you might end up with all the choosers selecting one of the shares and then the rest of the shares are not chosen by anybody. So if that kind of thing happens, then you just put everything back together and the choosers use the divider-chooser method to go from there. So you pretty much have to switch to another method if that happens, where everyone picks one share and nobody picks the other shares. Okay, then you just have to basically scrap this method, not scrap altogether, but you do need to use some other method to help along the way. All right, so let's say we have an example with Mark, Tim, Sarah, and Kelly. They're dividing a cake among themselves using the lone divider method. The divider divides the cake into 4 slices because there's 4 people. Now, it may not be 4 equal slices, you know, because remember the divider, whoever this person is going to divide it to how they are looking at the cake to see what they think would be equal in value. So then the other 3 are going to write down their preferences for their shares. Now I have a table in the next screen that shows the value of the shares to each player expressed as a percent of the total cake. Now, just like in the last problem where we took 500,000 divided by 4 to get the 125,000 is the fair share for each person. For this one, we're doing this as percentages. So there's 4 players, so each player should get at least 25% of what they view as the value. Okay, so when we look at the table, first of all, we need to figure out who's the divider. If you notice here, Tim has 25% all the way across. So that tells me that he is the divider because when he cuts those, to make those 4 shares, he cut it so that in his mind, all 4 shares are equal. So Tim is the divider. So then what we do is we look at Mark, Sarah, and Kelly and figure out what they get, and then the last person assigned a share is Tim, because according to Tim, they're all equal. So it doesn't really matter to him which one. So we're going to take a look at the preferences of the other 3 to figure out who gets what, and then Tim gets the one that's left. Okay, so let's look at Mark. Mark favors share 2 the most. So, and it's more than 25%. How do Sarah and Kelly see share 2? Well, those are less than 25%. So Sarah and Kelly don't see share 2 as their fair share, so there's really no contest there. Mark is given share 2. Okay, so share 2 goes to Mark. Now we move on to Sarah and Kelly. Sarah favors share 4, and so Sarah gave share 4 high ranks, right, 40%. Kelly, there's only one of these shares that Kelly sees as a fair share, and that's also share 4. So Kelly is going to be given share 4. She receives share 4 because it's the only one that is above 25%, which means Sarah cannot receive share 4, but luckily there is another share that is above 25%. So it looks like Sarah is going to receive share 3. We already talked about how Mark receives share 2, so that leaves Tim with share 1. Okay, so if you notice from this chart, the 4 shares are divided, are distributed where every player has a percentage that's at least 25%. So they all walk away happy, according to how they view the 4 shares. I'm going to check for some questions, see if there's any questions. I don't see any questions, so I'm going to go ahead and move on. Yes, so that's what I just said. Each person receives at least 25% of the cake, so each person receives their fair share. Okay, let's look at another method. It's called the lone chooser fair division method. And one player is the chooser. So before we had one divider and everybody else was the chooser. With the lone chooser method, we have one chooser, everybody else is the divider. So the process starts when there's a random selection to determine who is the chooser, and assuming there are two dividers, there can be a divider-chooser method to divide the cake into two pieces. So we're going to work with this with 3 players. So there's 2 dividers, 1 chooser, and the 2 dividers are using the divider-chooser method to divide the cake into 2 pieces. That's where one cuts, the other picks. Okay, so this is what we have. We have our cake, and as one cuts the cake and the other picks, so then we end up with divider 1 here with this piece and divider 2 with this piece. And then what happens is each divider then takes their share and divides it into 3 sub-shares. And the reason they're doing 3 sub-shares is because there are 3 players altogether. So that looks like this. So divider 1 divides his share into 3 sub-shares. Divider 2 divides his share into 3 sub-shares. And then what happens is the chooser selects one from each. And then what's left, divider 1 keeps what's left here, divider 2 keeps what's left here. So in the end, they each end up with 2 sub-pieces, 2 sub-shares. So divider 1 gets half, divider 2 gets half, like that is how we started. And then the chooser picks one from here, and then what's left goes to the dividers. So let's look at an example. Let's say that Brett, Amy, and Chris are dividing a vanilla strawberry cake. So there's the vanilla strawberry cake. Each person sees that cake differently. Amy says vanilla is worth $9, strawberry is worth $27. Brett says vanilla is worth $12, strawberry is worth $18. Chris says vanilla is worth $24, strawberry is worth $12. So notice something besides the fact that they all see the vanilla and strawberry pieces differently. Notice that they also see the value of the cake as a whole differently. 9 plus 27 is not the same as 12 plus 18. So the total value of the cake is even seen to be different as well. So let's suppose Amy and Brett are the dividers and Chris is the chooser. Brett cuts the cake so that the 2 shares are exactly the same. Each piece is half strawberry, half vanilla. So it looks like this. So share 1, notice with share 1 you have 90 degrees vanilla, 90 degrees strawberry. Share 2, 90 degrees vanilla, 90 degrees strawberry. Okay, that's what we're looking at for each share. Now, Amy is going to get share 1, Brett is going to get share 2, and according to how they view those shares will determine how they cut. Okay, so let's look at Amy first. Amy gets share 1, Brett gets share 2. How would Amy divide share 1 into 3 sub-shares? So we have to look at how Amy views vanilla and strawberry. Well, Amy thought that the vanilla half of the cake was worth $9. But now we're looking at half of the vanilla half of the cake, so it's only a fourth there. So half of the vanilla is worth $4.50 because the entire half of the cake was vanilla, that was $9. So we're dealing with just a piece of that. So the vanilla, 90 degrees of the vanilla is worth $4.50. And the same thing for strawberry. Amy thought that the strawberry was worth $27. That's half the cake, so we have to cut that in half because we're dealing with just the share, which is half of the strawberry. So that's $13.50. So to Amy, when you add up $4.50 plus $13.50. To Amy, share 1 is worth a total of $18. Now, Amy has to take that $18 and divide it up into 3 equal shares because there's 3 players. So that means each share, each of those sub-shares is going to be $6. Since we're dealing with 90 degrees of strawberry, in her share, 90 degrees of strawberry, and that's worth $13.50. When you divide it, you get 15 cents. So we have to figure out for all of these, when we're looking at a piece of strawberry or we're looking at a piece of vanilla, through the point of view of a particular person, like in this case, Amy, we have to determine what is the price per degree of that section. For this case, how is Amy seeing strawberry? What is the price per degree? It is 15 cents. So I take the $13.50 divided by 90 because it's 90 degrees. I get 15 cents per degree. So one piece of strawberry worth $6 is 40 degrees. How did I get that? Well, I need it to be $6 because it's $18 divided by 3. And when I take $6 divided by the 15 cents per degree, I get 40. So that tells me I need 40 degrees of strawberry to get $6. I have a total of 90 degrees of strawberry. So I could actually cut 2 pieces, 40 degrees each. That would only add up to 80 degrees. I have 90 to work with strawberry. So I cut one 40-degree piece of strawberry, that's worth $6. I cut another 40 degrees of strawberry, that's worth $6. So it looks like this. This is the share Amy has. And if we cut right here, this is $6. And if we cut right here, this is also $6, which leaves the rest over here, $6. Okay? So those are the sub shares for Amy. I'm going to check to see if there are any questions. In the Q&A box, I don't see anything. Okay, so now let's look at how would Brett divide his share S2 into 3 sub-shares. Half of the vanilla. For him, vanilla was worth $12, but we're looking at half, so that's 6. And for him, the strawberry was worth $18, but we're looking at half, so that's 9. So to Brett, the share has a total of $15 because I add 6 plus 9. So that means we need each sub-share to be worth 5. Okay, well, the 90 degrees of strawberry is worth $9 to Brett. When you divide that, you get 10 cents per degree. And I can use that fact to come up with where I would need to cut to have $5. One sub-share of strawberry worth $5 would be 50 degrees. And this is how I find it. I need $5, and it's 10 cents per degree. Divide those, I get 50. So I need to cut in the strawberry so that I have 50 degrees of strawberry in order to have a $5 piece. Okay, well, I have 90 degrees of strawberry, so if I cut 50-degree piece, that means I have 40 degrees of strawberry left, and it's 10 cents per degree, so that means the 40 degrees of strawberry that's left is worth $4. So I need another $1. So I'm going to have to go into the vanilla a little bit to get the other $1. Okay, so let's look at what the vanilla is worth to Brett. Well, it's worth $6 for the 90 degrees. And when I take 6 divided by 90, I get a repeating decimal. And if I round that repeating decimal, I end up with what's called rounding error, where my answer will be off by a little bit. So what I'm going to do, I'm just going to leave it like that. It looks kind of awkward, but it will make things accurate. So it's 60 over 90 per degree, okay, for vanilla. Well, I need $1. I need $1 worth of vanilla. So to get that $1, I'm going to take 1 divided by the 60 over 90, which gives me 15. So I need 15 degrees of vanilla to combine with the 40 degrees that are left of strawberry, because that was $4. This was $4, right? I need to combine this 15 degrees of vanilla with 40 degrees of strawberry to get a total of $5. So this is what Brett's share looks like. He cut here to get this $5 piece, 50 degrees of strawberry, and then he cut again here to get this $5 piece. Remember that 15 degrees of vanilla is $1, and the 40 degrees of strawberry is $4. So then that means the rest over here is $5. So those are the 3 sub-shares that Brett found with cutting his share of the cake. I'm going to check the chat box and the Q&A box, see if we have any questions. Okay. So I don't see any questions. All right, so now let's, the next step is to have Chris choose, because Chris is the lone chooser. He's going to choose 1 sub-share from Amy, so one of those pieces that was cut, that Amy cut, and 1 sub-share from Brett. So in order to figure out which one Chris would choose, we have to see the cake how Chris sees the cake. How does Chris see the cake? Well, he sees the vanilla half of the cake worth $24, and that's half the cake, so that's 180 degrees. So if you take 24 divided by 180, then you see how much it is per degree. He sees the strawberry half of the cake as $12. So if you take, which is a half, so it's 180 degrees. So if you take 12 divided by 180, you see how much he sees the strawberry part per degree. And I'm leaving those as fractions, awkward fractions again, because if I divide them, I get a repeating decimal, which when I round, my answers are not exact. So I'm just leaving them as the awkward fractions. Now, let's take a look again at Amy's sub-shares. Okay, she cut here and here. Oops. She cut on these 2 lines. Let's look at how, this is how Amy cut, but let's look at how Chris sees these pieces. We have 40 degrees strawberry, and if I take 40 times the price per degree for strawberry, that's the price per degree we saw for strawberry, we get $2.67. So according to Chris, this is worth $2.67, and this one is also worth $2.67. But what about this piece over here with the vanilla and strawberry combined? Well, 10 degrees strawberry, and he sees strawberry as 12 over 180. 90 degrees vanilla, he sees vanilla as 24 over 180. That gives me a total of $12.67. So guess which piece Chris will choose? That one. Because according to Chris, that has the most value. Okay? Let's take a look at, so Chris is going to pick this one. That would be for Chris. That means Amy is left with those 2 pieces. Yeah, that's what I just said. So Chris picks this one. Amy has these 2 pieces. So Amy has a total of 80 degrees strawberry, and Chris has 90 degrees vanilla, 10 degrees strawberry. Okay, now Chris looks at Brett's pieces. He has a 50 degree strawberry piece. Well, according to Chris, strawberry is worth 12 over 180 per degree. So that's $3.33. So that's this piece right here. 50-degree strawberry. Then for the part strawberry, part vanilla, well, 40 degrees times 12 over 180, and then 15 degrees times 24 over 180 is $4.67 there. And then when you look at the 75 degrees vanilla piece right here, that is $10. So guess what Chris picks? The $10 piece, and then that leaves Brett with this piece and this piece. Okay, so Chris is going to choose this 75 degrees vanilla and leaves Brett with the other two. So this piece here goes to Chris, and then the rest, these other two pieces, this is Brett, this is Brett. That's how it ends up. So does everyone in the situation feel they have at least their fair share? Let's check it out. To Chris, this is what the cake is worth. $24 for the vanilla half, $12 for the strawberry half. That's a total of $36. So in his mind, he should have at least $12 worth of cake for his fair share. If we take a look at what he picked from Amy, he picked the 10 degrees strawberry, 90 degrees vanilla. So 10 degrees strawberry, 90 degrees vanilla, we saw that was $12.67. From Brett, he picked the 75 degree vanilla. We saw that was $10. So when you add that together, $22.67. So yes, he walks away feeling very happy because it's way over. He was supposed to, his fair share is just $12. So he's way over the $12, so he walks away very happy. Let's see what happens with Amy. She was left, the cake that Amy is worth $36 total. When you divide by 3, it's $12. So fair share for Amy is also $12. Now Amy was left with the two 40-degree pieces, which is a total of 80 degrees of strawberry. Well, 80 degrees of strawberry, when it's 15 cents per degree, is $12. So she met the criteria of the at least fair share. Fair share for Amy's $12, and the two 40-degree strawberry pieces does give $12. So she walks away happy. Let's see what's going on with Brett. To Brett, the cake is worth a total of $30 because he assigned $12 to the vanilla half and strawberry $18. So when you add that up, you get $30. So his fair share would be $10. Now, Chris took this piece. So Brett is left with that piece and that piece. Let's see what, according to Brett, those fair shares are. Okay, 50 degrees strawberry. He sees strawberry is 18 over 180. I switched to over 180 because it's half the cake. $18 for strawberry, that's half the cake, that's 180 degrees. That's $5. Then 40 degrees strawberry, 15 degree vanilla piece. He sees the strawberry as $18 for half the cake. Vanilla is $12 for half the cake. That's $5, and when you add them together, you get 10. So Brett also met the fair share, the minimum of $10. Brett received, in his mind and how he sees his pieces, $10 worth of the cake. So all three players in this situation ended up with at least their fair share in their mind and how they view the cake. I'm going to check again for any questions. Yes, there was a question about the access to the presentation as a complete video. When I am done with the presentation, I upload it into YouTube, and then I will email your instructors the link, the YouTube link. but you don't have to wait for the link. I mean, once it's uploaded, you can always just search for it in YouTube. So I'll email the instructors my file that I used in this presentation. It's a PDF file, but then also you'll be able to see this in YouTube. And it does take a while. The process of transferring this recording to YouTube takes a couple hours. So it's not going to be available immediately, but it will be up in YouTube, should be by the end of today. So you will be able to view the whole presentation again. That's a good question. Okay, I'm looking for any other questions in the chat box or in the Q&A. I don't see anything. Okay, so I just want to summarize that we discussed the elements and assumptions in a fair division game in this webinar, and we did several examples of fair division methods. If you notice, there's not just one method out there. It depends on the number of players a lot of times on which method you choose, because you can't do divider-chooser with 5 players. You know, divider-chooser only works with 2 players. So, but you know, there's more than one method for fair division. And this is my email address, so if you have any other questions, feel free to email me. If your instructor doesn't post the notes for this webinar, this PDF file I used, you can always email me and I'll email it to you. I'll just attach it to the email and reply back. I also wanted to mention that this webinar is not meant to cover the entire chapter on the math of sharing. I was not able to get through every possible scenario or example that you will see in the homework. So like for instance, the very last section of chapter 6, I was not able to get to that because I need to keep this within an hour. So please still read the book, watch the videos in my math lab, but I did want to provide some explanation because I think what's difficult with this topic is that people think that dividing it up equally means physically it looks equal, like a subdivided equally would be, a foot-long subdivided equally would mean you cut it on the 6-inch line. But that is not what we're talking about here. It's looking at it, is it fair in the eyes of the person looking at the sub? So you have to put your perspective in the mind of the person doing the choosing or the dividing to see what they would do. And that takes a little getting used to. So I hope this webinar was helpful in that way. I do appreciate you taking the time to visit, you know, and watch and take the time to listen. And I'm gonna look, see if there are any other questions. Someone posted about how there are no words to describe how helpful this was. I'm so glad that this is helpful. And like I said, the YouTube video will be up. It'll be up in YouTube hopefully by the end of today, and you can have the PDF file for your notes. So I appreciate your time and attention and being able to log in and to this webinar, and have a wonderful, blessed rest of the day. I'm going to go ahead and turn off the recorder.